Hello and welcome back to Introduction to Chemistry. In the last lecture, we talked about Dalton's atomic theory. But you might be asking yourself, what exactly is a theory? And what process did Dalton use to arrive at his theory about atoms and molecules? It might surprise you to find out that you've been using the same process Dalton used to come up with his atomic theory all the time. That process is called scientific reasoning. Sometimes the process is summarized in something called the scientific method, which is often actually considered a collection of methods. But let's look at an example of a scientific method. Every day throughout your life, you're making a whole bunch of observations. In fact, let's talk about some observations you made when you were an infant, because you've been doing this process for your entire life. At some point, whoever was feeding you got tired of spooning food in your mouth, and they handed you an eating utensil. Probably it was a spoon. You made lots of observations about that spoon, what it tasted like, what it sounded like when you whacked it on a surface, how you could scoop food with it. At some point, you probably accidentally dropped it because you weren't very coordinated, and you made an observation that someone came and got it for you and gave it back to you because you were well cared for. After a while, after accidentally dropping it a few times, you might have come up with an idea in your little baby brain, and that idea may have been, that person keeps bringing me back my spoon. I bet if I drop the spoon again, the person will bring me the spoon. In other words, you may have come up with the idea that the reason why that person was there was to bring you your spoon back. Eventually, like all infants, after you had developed this hypothesis, that's the fancy word for your idea, you predicted that the person would bring you the spoon, and you decided to do an experiment. And here's how that experiment went. You held your hand up. You looked at the person who was supposed to bring you the spoon. You dropped the spoon, and you looked down to see where the spoon went. And then you looked back at the person who was supposed to bring you the spoon. You did an experiment to see, would that person bring me the spoon again or not? In other words, you made a new observation. And that new observation about whether or not the person brought you the spoon either supported or refuted your hypothesis about why that person was there. Now, if a hypothesis is supported by many experiments done over a series of time by a bunch of different people, then that hypothesis becomes glorified by the more dignified name of a theory. Now, some people think, well, a theory is just a guess, but that's not true in science. In science, a theory is something that has been supported by many experiments, and it hasn't been shown to be false by any of those experiments. A theory must be falsifiable. In other words, there might at some point in the future be an experiment that shows the theory is not correct. But most scientific theories that you see published in books have been supported by all of the experimental evidence. Another thing that sometimes happens when people do many experiments is that they collect some of the experimental observations into something that they can make into a mathematical formula, and that is usually called a law. So at this point you might be wondering, okay, sometimes I have a theory and sometimes I have a law. What's the difference between a theory and a law? Well, a theory applies to all events over a long range of time, and it explains why things happen. A law, on the other hand, describes what happens, perhaps in the form of an equation, but it doesn't try to explain why things happen. That's what a theory does. Now, sometimes students are confused about what's the difference between a hypothesis and a theory. A hypothesis and a theory are both very similar, as you can see. They both explain why something happens. But a hypothesis is an explanation of why something happened today, to me, to a small number of events, whereas a theory is an explanation of why something happens that applies to all events over a large period of time. The same can be true said about the relationship between an observation and a law. An observation describes what happens in the moment, where a law describes what happens all of the time. Let's apply what we've learned about the scientific method to these balloons. The first thing I'd like you to do is make some observations about these balloons. No observation is too obvious. Go ahead and type whatever comes to your mind. Great! Now, the types of observations that students usually make include things like both balloons are floating, both balloons are tied to strings, the balloons are different colors. Those are all perfectly good observations. Sometimes students delve into the territory of hypotheses when they're making their observations. Now, you made the observation that the balloons were floating. That meant that the substance inside of the balloon was less dense than the air. So some of you said, I bet those balloons are filled with helium. But you can't observe the helium. So that's a hypothesis, not an observation. That's your guess about why the balloons are floating. Others of you might have said, well, I think they're probably filled with helium. But I'm a history buff, and I remember the Hindenburg. The Hindenburg wasn't filled with helium. It was filled with hydrogen. It was a balloon that floated, but it wasn't filled with helium. So there's a couple of gases that I can think of that might be causing those balloons to float. Helium or hydrogen. Well, we have some hypotheses now about what the balloons might be filled with. What do you predict will happen if we pop the balloons open? Let's make a prediction about these balloons. Do you predict that the balloons are filled with the same gas and that the same thing will happen to both balloons when we pop them? Or do you predict that the balloons are comprised of different gases, that they're filled with different gases and different things will happen when we pop them? Go ahead and record your answer. Do you think they're filled with the same gas? Or do you think they're filled with a different gas? And which gas do you think is in these balloons, hydrogen or helium? Okay, now you've made your prediction. Let's go ahead and do the experiment. Let's use a candle to pop the balloons and see what happens. Let's make some observations about what happens when we pop the balloons with a candle. Now this first balloon, here comes the candle. It's going to hit the balloon. All right. That was interesting. Now let's see if we can make the same observation when we pop the second balloon. Here comes the candle. Did your observations support or refute your hypothesis about what was in those balloons? Did you guess correctly? If you did predict correctly, would you like to say that your hypothesis is also a theory now? In other words, for balloons that float, must they be filled with hydrogen or helium? Or do you think that your prediction only applied to that one particular set of balloons? Again, if the observations can be collected into an equation, like a mathematical equation, then we would call that a law. I hope you've had fun today using the scientific method.